today, as Tim said, I'm here to talk about my project Dry 7 and how that's helped position Westland milk products into value-added products. So a bit of an overview of what we're going to talk about today is why Westland and why me, Westland's strategy and how the D7 project fits into that, a bit about the team structure and responsibilities of the project, what challenges we faced, what we learnt and how we were successful. And finally, always, where to next? So why Westland and why me? So born and bred in Westport on the west coast of the South Island, I was very lucky to receive the Westland Milk Products Scholarship in 2003. I headed off to Canterbury and did my bachelor's in chemical and process engineering and stayed on for a 5th year to do masters in engineering management. During this 5 years, I spent a number of times in the school holidays scrubbing and cleaning the floors in the powder factory, inside the stainless steel, and literally learning how the process worked from the ground up. After finishing my degrees, I moved back to Hokitika and worked my way through the site, helping in the technical department and then moving into the process engineering role. I became the assistant manager of the powder department, and in 2014, I think it was, January, became the project manager for Dry 7. More recently, in September last year, I was appointed the Senior Nutritional Production Plant Manager. And that's me in front of our 100-tonne panel, which is quite a proud moment. Anyway, who's Westland? So Westland historically has produced butter, whole milk and skim milk powder, as well as protein products for the international and domestic markets. The cooperative has been operating since 1937, and in 2001 our shareholders voted to remain independent from Fonterra. So this was a key turning point for our company. Westland has become the 2nd largest dairy company in New Zealand, as well as the 7th largest food processing company. In 2015 we generated a revenue of 640 million on the back of very low dairy prices. Today we have over 620 employees in Hokitika, Rolleston, Auckland and Shanghai. There are 430 supplying farms milking nearly 200,000 cows. And we have quite a unique catchment area, 440 kilometres from Fox Glacier through to Karamea, and also some supplying farms in Canterbury and Rolleston. So our challenge, Westland is crucial for the survival of the West Coast community. The company contributes millions of dollars annually into the region's economy, and since the collapse of coal prices and the demise of solid energy, our success has become even more critical. However, the continuing downward pressure on dairy prices has resulted in an unsustainably low payout and increased economic pressure on our farmer shareholders. So how are we going to solve that? The solution was to reposition ourselves into value-added products to increase any economic returns to our shareholders, ensuring the sustainability of our business for future generations. And the strategy to do this has been a dual strategy, focusing on productivity and growth. On the productivity side, we embarked on a Westland Way for Excellence program and also growing our milk supply. And we did this by installing a RO milk plant in the Rolleston facility. On the growth front, we have enhanced our customer and product value and also expanded our technology, which is stage 2 and 3, and this is where Dry 7 fits in. So the objective of Dry 7 was to build and operate a nutritional spray dryer in Hokitika to contribute 13,000 to 23,000 metric tonne to the nutritional strategy over the first 3 years. And of course to meet the key target date of commissioning in September 2015. So the images you can see on the right here is what the 3D model predicted the plant was going to look like on its completion next to Dry 6. Westland chose to work with 3 key partners, Babbage Consultants Limited for project implementation and facilitation, and also Tetra Pak as the head contractors for the process design. We also chose a local firm, Evan Jones Construction, to do the civil construction, who've done the other dryers on our site. Right, so the project structure was set up as shown in this diagram. What I'm trying to demonstrate here is the complexity of the project. In particular, my role as the Westland Milk Products Project Manager was to manage this complexity and ensure that all competing priorities were brought together successfully. A key part of my role was to interface between Babbage, Tetra and Evan Jones with the Westland team to ensure the project was completed to the highest standard required for a plant that makes infant formula. My engineering background and combined with my process knowledge and operational experience meant I was Westland's choice to lead this project. So what I'm going to show you now is a little bit of the complexity in each of the areas. Let's start with process design. So there were 5 main processes within the build. The material handling and wet mix system, which was not only the physical stainless steel to put the equipment in, but the automated recipe system to ensure the right amount of ingredients went into the product. Evaporation via falling film evaporator for both the nutritional and whole milk powder configurations. We chose a tall form Tetra Pak multi-stage dryer and a GEA Avapack limited intervention packing line to pack out at 8 tonne an hour, and the palletizer to make sure it looked good on the pallets. Overarching all of these is the clean in place or CIP process to ensure that the hygiene standard of the internal equipment is maintained. So the civil, product and people flow group, they looked after the building primarily. So the building itself was 35 metres tall and has the highest building on the Hokitika site now, reaching the top of the dryer exhaust stacked at 41 metres. There were 4 stages to the building. Firstly, the material handling area, which was built within an existing store. This needed to be ready by February 2015. Also, the dry tower, amenities, store and container loadout, which needed to be completed by September 2015. Alongside this, there were services buildings, utility civil works and the groundworks. So the groundworks are just reaching final completion now. We had a very constrained construction site in the middle of a fully functional operational plant. The key requirements for this team involved making sure all of the quality requirements to meet the Ministry of Primary Industry regulations were met, including building filtration, positive pressure, temperature, humidity control, and ensuring that our wet and dry segregations between areas were met. On top of all this, the whole site required a services upgrade to handle the new demands from Dryer 7. In particular, we needed 2 new feeders of 11 kVA brought into site. We had compressed air and chilled water shortages that needed to be upgraded. We needed a new nitrogen plant and a larger CO2 tank. We also had additional infrastructure for pipe bridges and supply of water across the process water ring main and a steam tie-in from the 2 new boilers. On top of this, our DAF plant, so dissolved air flotation plant, where we treat our effluent wastewater, that was also constrained, so we needed to upgrade that to deal with the new Dryer 7 plant. You can see significant work fronts happening on the right there. That's pipe bridge on the right is right across the access road, which made it quite difficult for the tankers to get through, but we'll talk about that a little bit later. So alongside all of that is the unknown of an IT system, specifically an enterprise resource planning system. So this part of the project focused on ensuring what we had set up for D6 could be expanded and rolled out across to Dryer 7. We also needed to scope the software and hardware requirements for admin networks, including the switches, cabling and licenses. Overarching all of this was to make sure site security was secure. Throughout the project there had been a dairy industry scare of 1080, so it was even more important that the site was secure during and post the implementation of the project. So back to quality. So quality in its own not only bridges all of the teams, but it is a topic in itself. And quality was really important in a plant that makes infant toddler nutrition, definitely for export markets, including China. So what was really important was ensuring that this team created the quality systems to ensure that we met our quality sign-offs with the industry. We also had to transition the construction site into red line processing level of hygiene, and given that we had the wettest winter on history in Hokitika in 2015, I think we pumped water every day trying to dry the place out, and that left along its own amount of dirt and silt to then clean up. We also needed to keep the building at a quality level so that our customers could come and view the building to sign it off for their product to be made. So alongside the technical, mechanical and civil parts, there's a softer side of life, which is ensuring that our people and their training and recruitment got sorted out. So we needed to set the standard of what the new nutritional plant was going to be. IF products, as we said before, require a higher level of quality than commodity whole milk products, and we needed to communicate that to the team and set the vision for what our department was going to be. We spent time focusing on our people capability, specifically about competency and having a higher level of focus on actions and data, and to also make sure they were thinking about what solutions they could implement if they need to. Alongside the Westland internal HR stuff, there was the Tetra Pak portion of this to ensure that all our staff got trained on the new process and the new building for commissioning. So the operational team, that was made up quite a lot of people out of the other groups to ensure we had a cross-functional group of people understanding how the site worked. You can see on the left there, with a little red button, that's an image of our milk supply curve, which peaks in October at over 4 million litres of milk per day. So we have about 25 tankers which deliver 30,000 litres of milk each day. So it was critical that whatever the project was doing, where the crane was sitting, that the tankers could always get through to milk reception to unload. So the key task for this team was to ensure that the project conflicts and the operational site requirements never really clashed, and we always had to do some decent risk analysis and project planning to make sure both could operate in harmony. For example, we needed temporary walls so that we could process on one side of the wall and build on the other. So budget challenges. I think every project has its budget challenges, whether they be large or small. So we started off with a total budget cost of just under 102 million, with a contingency of only 3.8. This was all going well until about the end of early 2015, we realised that we needed more money. So we had to go back to the board for an additional 10.4 million, and that brought our budget up to 112 in total, or just after that. Some of the overspends that contributed to this was needing to change the earthquake strengthening of the building from level 3 to level 2, that steel prices were underpriced at the time as part of our budget estimates, and also we had delays in timeline which resulted in additional costs trying to speed it up. Westland also changed some of its site health and safety expectations, and lifting the quality standard also resulted in more money being required. Throughout the project, we were continually reviewing the scope to see what we could take out or identify any savings, and this really ramped up a notch when we realised we needed so much more money. In particular, the plant and goods lift was the first thing to go, so instead of leisurely moving your way up the 35-metre tower, you now have to walk several hundreds of stairs, but we have fit operators, and I'm sure they race at night shift carefully so they don't slip. Yep. And what did we learn? I think in particular for me, I learnt these top three things: that clearly defined site standards are key. So we had a lack of engineering standards, which made it hard to ensure we're actually maintaining our site standard. By them not being documented, it was very hard to say this is what we expect when the contract was saying something different. That consultative process is good, but it can also hamper progress at times. You really need a key decision maker who's got the authority to do so. And resource utilisation is always difficult when you have business as usual tasks, but at times these did distract more than we expected. And success. So we were successful. We achieved our first product on the 6th of October, and we achieved partial takeover on whole milk towards the end of that month. We've had initial nutritional powder production, which has given us a very functional powder that's comparable to what we make on Dryer 6. We achieved our production rates of 4 and 5 tonne respectively on whole milk and infant formula, and these were what the contract had guaranteed from Tetra Pak. We also on the quality front achieved MPI sign-off, and 2 customers have approved this plant for use. Our external audits are impressed with the standard of build, so that's a great positive. And where to next? So for Westland and I, it's to achieve takeover and project acceptance this year, hopefully in the next couple of months. And I'll continue to meet and exceed our business KPIs, and to continue to build the nutritional plant culture and ensure that we are world class. And obviously together we'll reposition Westland to achieve our mission statement, which you can see there. So where to from there for my career? Will there be D8? Will there be GM? Or will there be CEO in my future? I'm not sure, but it's always important to aim high.